In this section, we'll be looking at how to deal with the sum of a geometric progression. In the introductory videos, you've already seen the general formula for the sum of a geometric progression, where the common ratio is bigger than 1 and where the common ratio is less than 1. How to change and use the different forms that will fit the ideal situation in the problem. Let's look at a set of questions that illustrate this. Number 1, find the sum for the given number of terms of each of the following geometric series. A, 2, 6, 18 for the 10 terms. B, 1, half, 4 for the 8 terms. We are going to find the sum of terms. That is what the question is asking of us, to be able to find the sum of terms. So the first problem gives us like 2 sets of sequence. And these 3 sets of sequence are said to be geometric sequence. And we want to find the sum of a given number of terms. And it goes on to state the number of terms actually. So we'll see how that works there. First part of it says that you have 2 plus 6 plus 8. And for all of that, we want to look at the sum of the first 10 terms. How do we do that? Remember that for a geometric progression, as the introductory part of this section of geometric progression made us aware, the sum of any number of terms is given as Sn, okay? For emphasis, let's just keep that somewhere here. Sn, the sum of the terms of a geometric progression. This is given by A into bracket, r to the power n minus 1 all over r minus 1. Okay, now you use this form like the introductory aspect mentioned when your r is bigger than 1. Or look at the denominator. You realize that we are subtracting 1 from the r. So since the sum of a geometric progression should be giving us something positive, the expectation is that we logically want to have something positive, and therefore the ratio has to be bigger than what we are subtracting. We have more than what we are taking away. That is what happens if your common ratio is greater than 1. But if your common ratio is less than 1, again, the principle works. You should have something bigger. Then out of the bigger sum, you take that away. In that case, this section will be reversed, and you will see that as we go along. But we'll just make do with this. All right, so A, r to the power n minus 1 all over r minus 1. Okay, you saw that in the introductory part, so let's not take so much time here. And we want to sum of the first 10 terms of this. The only thing that is missing is the common ratio, and we should be able to find that out. Right? You should be able to find that out. Okay. I think that this is 18. Yes, that was what was in the problem. 18. Okay. 2 plus 6 plus 18. We divide the succeeding term minus the preceding term. Hence, our common ratio here will be 6 over 2, and that should give us 3. Okay, 6 over 2, that should give us 3. What is the sum of the 10 terms? So S10 will be A. What is your A? 2 into bracket your R, 3 raised to the power n minus 1. So now because we are looking at 10, 3 raised to the power n all minus 1, 10 minus 1 all over R minus 1. So we're going to have 3 minus 1 here. Hence, your sum of your 10 terms should be 2, 3, 10 minus 1 all over 2. Okay? And that should simplify to give you 3 raised to the power 10 minus 1. You don't need to use your calculator to work that out. No. In examination, most times you just be required to just leave your answer in this form. Where need be, that should be easy to evaluate on the calculator. All right. Then the other part, the B part, will also give us a geometric progression that was of the form 1 plus half plus 1 over 4. And in that case, we wanted to find the 8 terms. Some of the 8 terms, the same principle goes. But let's look at this carefully. If you find the common ratio, you realize that the common ratio drops. Because half divided by 1 is half. A quarter divided by half will give you half. So here you have the common ratio being a fraction, like dropping, in which case your r will be half. So what? You see that your r is less than 1. Do you notice that? That is why I just said, and for emphasis, that when you have your common ratio being less than 1, when the common ratio is less than 1, guys, you still use the sum, but you only change the positioning of that. So instead of r raised to the power n minus 1, you write 1 minus r to the power n. And instead of 1 minus r, you write, instead of r minus 1, you write 1 minus r. That is what you do if your common ratio is less than 1. So here, we want to find the sum of the a terms, and therefore, we'll make that adjustment accordingly. It wouldn't make any difference if you were to put it straight away. Obviously, you still come to the same answer. You can try that in other separate activity, but in an exam condition, just get that. My common ratio is less than 1, so my denominator should be 1 minus r. Okay, so let's find that a sum of our a terms will be a into bracket 1. Our a is 1, so let's just keep that in, okay? So 1, then you have our common difference, our common ratio, sorry, half raised to the power 8 minus 1 all over 1 minus 1 minus half, okay? So that should work out as 2, then a half raised to the power 8 minus 1. So that should work out to give you the sum of the a terms in your progression. The sum of the a terms in your progression. When you're able to do that, I'm sure you should be able to work out and get the answer nicely there.